Hello everyone. In this video we're going to use chi-squared test of independence in order to analyze the customer preferences across shopping platforms. So we collected a random sample of 300 customers and then we investigated their shopping preferences and their age group, and we are trying to figure out whether these two factors are dependent or not. Alright, so the data is over here, is in this table. We have three groups from 18 to 29, 30 to 49, and 50 and plus. And we have three categories of shopping preferences: online shopping, retail stores, or mobile apps. So the traditional method is to use, so chi-squared test of independence is having usually 5 steps. So the first step is to state the null hypothesis and the alternative hypothesis. Step number 2 is to find the critical value. Usually we use the table before, but now we're going to do it on Excel. Step number 3, you're going to compute the statistical test, and this is basically most of the work what we're going to do on Excel. So here they are the formulas, we're going to use them later. And step number 4, we're going to use basically the data that we collected from test statistic and the critical value. We're going to make a decision accordingly, right? Finally, you want to summarize the data according to your problem. So here we are investigating whether the two factors are dependent or not dependent. Just you have to come up with the correct independence test result, right? Okay, let's get started. So step number 1 is always the same, and H0 is going to be stating that the two factors are independent. And in this case, the two factors are the columns and the rows, basically the preferences versus the age group. And H1 is going to be always dependent. All right, and if it is dependent, again the preferences are dependent on their age group. All right, great. So now let's get into Excel, and this step that we're going to do right now is going to be step number 3. I'll get back to step number 2 in a moment. So this is my observed data, right, as you receive it, the table on the problem. And what I'm going to do, so I'm going to add another column here, and I'm going to put percentage on it. So this is going to be a new one, and it's going to supposedly help me further on with the calculation. So what I'm going to do is really simple. You're going to take equal sign there, and then you're going to click on this number, the total, and then divided by the overall total, which is 300. And then you want to fix that the last one, so 300, you need to lock it. And the way to do it on PC is F4. So here, if you don't have a PC or you don't have a F4 on your screen, so the only thing you gotta do is put a $sign before the letter and type another $sign before the number, and this should be fine. So what's he gonna do? The locking key there on the 300. So this is gonna allow me to drag it down, and if I double click on this, so you see is automatically dividing this 100 over 300. All right, so this one is going to be automatically dividing the 100 here divided by 300 here, whatever number there, right? Okay, great. So now what I'm going to do, I'm going to copy this table. Okay, and then I'm going to paste it here. So as you can see, I paste the tables in order to go faster, right? So you can paste it as values. So it's really important to be values here, right? You don't want to have any formula locked in there. And if you want to get the same format. For example, you can click again on same cell and you can use this brush over here, so that's gonna give you the same format. So you see it became yellow, so the same format over there without changing the numbers, right? I don't want that, I want to go back, so I'm gonna keep it in blue, right? Okay, so now the next step, I highlighted the data as you see here is in yellow. Everything else is extra, so this is a total, is not part of my data, and the only data that I have are the yellow data over here, right? So that's the observed data, and so far they are the same. So what I'm going to do, I'm going to select that yellow data and I'm going to delete it, so I don't need it anymore. And then in here I'm gonna start pasting the expected value. So this table should be called expected table, right? So now the formula you're going to be using is the expected count is the rows total times the column total divided by the grand total. And if you remember, the rows total are the 100 over here, right? And the grand total is the 300 for this one. So what I'm going to do, since I have this, is easier to multiply these percentages over here that I did it already times the total of the columns. So in other words, let me zoom in. So in this cell here, I'm going to put an equal sign. I'm going to select the percentage multiplied by the total of the columns. That's what I'm going to do for all of them. So for example, for this one, what's the intersection? And you can see it, the 110 here with the 0.33, right? So you're going to be equal sign, I click on this cell times this percentage, and you have to do it for all of them. So either you can do it by hand, one by one, or either you can lock a cell as well. So for instance, if I want to drag it down here vertically, so I'm gonna have to lock this cell 100. All right, the 100 is in red, so I just go click on F4 here, and that's it, enter, and then drag it down, so you can find the other numbers. You can always double check by double clicking on any of the cells. So for example, this one, is it really the cross? Yes, the 0.33 times the 100 here, right? And obviously I can do this one either vertically or horizontally, but I'm going to keep doing it vertically. So I can shoot this cell over here, double click. So I want to lock the 100 because I'm going to drag it vertically. So I'm going to put on the blue one, make sure the cursor is in the blue one, and then you type on F4. For me on this computer is function and F4, all right? It could be just something different for different computers, right? And then I click on this one. Whenever you see this small square here, you can drag it up, or you can copy and then paste over here, and there you go. Okay, so let's do the last one. So the last one, I have to do the first cell first. So which is equals to 90 times this, and then I'm gonna lock the 90. So function F4, enter, and then drag it down, right? And you get all the expected values. Great. So now what we're gonna do is the statistical test value. This is the statistical value for chi. And what the formula, this is your formulas, right? So for each of the components in here, what you're gonna do, you're gonna use the parentheses, you're gonna put the observed value minus the expected value, you square it, and then you divide by the expected value. And finally, you have to do the sum of all these values. All right, so let's go to Excel. It's not so difficult. So for this purpose, you need to have both tables in front of you and plot this one, right? So let's go with this cell. So this cell has to be literally under this first column. All right, any place on the first column but under it, right? So you're gonna be equal sign, open a parentheses, and then you're gonna click on the observed value in yellow, minus, you're gonna click on the corresponding expected value in blue. So first one first, close the parentheses, and then you're gonna use shift 6, that's exponents, 2, and divide by the expected value. So you have to click on the blue cell one more time. All right, and enter. So you don't really need to do another one, but okay, I'm gonna do it again, so probably I have a better view here. So what you're gonna do is equal sign, you're gonna open a parentheses, you click on the 45 on the observed value, minus, you click on the expected value, which is 33.3 here, close the parentheses, shift 6 to put the exponents, 2 divided by expected value again. So you have to click on this cell one more time and enter, and that should do it. And then once you are here, you're gonna click on that cell and you're gonna drag it on the side and below, right? So those are all the values that you're looking for, all the chi-squared components. All right, now I'm gonna apply this formula, which is chi-squared right now. This is chi-squared test, and the only thing I'm gonna do, I'm gonna add them up. So sigma, whatever your symbol here is the sum. So this is my chi-squared test, and this is going to be equal sign, and type in sum, open a parentheses, and select everything in this table, close the parentheses and enter. And this is actually your step number 3. That's what you're looking for, right? This is the value that you are looking for. Okay, moving forward, so here we have the data. The level of significance for this problem is 0.05. The number of rows, we had 3 rows. The number of columns, we had 3 columns. And what I'm going to do here, I'm going to look for degree of freedom. And as you can see here, degree of freedom is going to be r minus 1 times c minus 1. I'm going to plug it in, so maybe you're going to use this table again for a different problem. So I'm going to be doing equal sign there, open a parenthesis, so rows minus 1, let's click on the 3, minus 1, close the parentheses, and times, open a parenthesis again, so number of columns, we see 3, click on 3, minus 1, close the parentheses. And this would do the calculation for you. That's going to be a 4. All right, so let's move on to the second table, and I'm gonna start with moving the chi-squared test over here. So I'm gonna copy it, equal sign, and click on this, and that's already done. Now I could calculate the p-value, and I could calculate the critical value. So let's go with the critical value. So the critical value is using this function over here, which is chi squared inverse RT. RT stands for right tail, right? Then you have to put the alpha value, and then you have to put a comma and then degree of freedoms. So let's start with this, equal sign. So as soon as you type chi, you can see the list of functions. You can choose the inverse, which is this one. Double click, and you get the function ready for the variables. So the variables, the first variable is the probability, which is the alpha value. And this is my alpha value, level of significance. Comma, and then degree of freedom, you click on 4, close the parentheses, and done. So your critical value is 9.48. Now we're going to do similarly with the p-value, but with a different function. And the function we're going to be using for the p-value is chi-squared distribution RT, right? And again, we're going to use the test statistic and degree of freedom in this case. So equal sign, type in chi, and you select from the functions. That's going to be the second one. You transfer it there, and then you put the x value. So what is the x value? Is the chi-statistic test. You click on this, comma, and then degree of freedom, you click on this and close. All right, so your p-value is 0.01. All right. Okay, so I just want to explain briefly right now how do you make the conclusion. So as you can see here, on this is my chi-squared chart, right? And what happened, this is the cutoff, so between accept and reject. So if you are falling behind this line, you're gonna be rejection. So this side is rejection, and this one did not reject, right? Now this is the line of the alpha value. So what is the alpha again? Is a probability, so it's an area. All right, so the area, the pink area over there. And by calculating the p-value, which is this one over here, that's another area as well. So if the p-value is smaller, so you're gonna stop here, let's say, right? So this is your p-value. If this is my p-value, then I'm within the rejection zone. So p-value is smaller than the alpha value. If the p-value is bigger than the alpha value, so you're gonna make a bigger tail. And you see the end over here? That's gonna end within the not reject zone. Please remember that the p-value always related to chi-squared test, and the other value, which is the alpha value, this one, that's going to be chi-squared critical. For us, the critical value was a 9.48, and the chi-squared statistic was 17. So 17 is going to go further here. So this is your chi-squared critical over here, right? It's going to be somewhere here, all right? So you see the critical value is within the rejection zone, all right? So you're going to make a conclusion reject. So on Excel here, what we want to do is we want to read the values directly from the table. And for this purpose, we're going to use a formula here, the if statement. So we're going to put if equal sign first, and then if, and then open a parenthesis. And we're going to put the logical statement. So we say if alpha value is bigger, so if the alpha is greater than the p-value, that means the p-value small, we're gonna put a comma there, and then we're gonna put the statement, what you want to do for the statement. So we're gonna say, so reject the null hypothesis, and close the quotation. It has to be a quotation there, right? And then you put another comma and open another quotation, And for the other scenario, the alternative scenario, you're gonna be do not reject, right? And then close the quotation and close the parentheses. So as soon as you put enter here, it's gonna give you the correct statement, which is reject. And you remember we said reject, right? We're gonna fall over here. So that's basically all, right? We know we're gonna reject the null hypothesis. Step number 5, what you can do is, so you can copy this statement over here, same conclusion. However, we're gonna switch this one, reject the null hypothesis. So whenever you reject means you are in hypothesis H1, right? And this we're gonna substitute it by this cell over here. We see the preferences are dependent on their age group. And for the other one, do not reject, we can change it. You have to take the quotation as well and then click on this cell to put the other statement. So do not reject A0 means accept A0, which is the preferences are dependent on their age group. And here, as soon as you put enter, of course, it should be the right statement. We see the preferences are dependent on their age group. And that's all. I hope this helps.